at some basic principles and we looked at some concepts of logarithm, and we've also understood how to look into different ways of writing a certain terminology or a certain expression involving log. Now, if you look at the concepts that we have here, these are the rules of logarithm that you have to know. Okay, you have to know. So law 1, log AXY equals to log x plus log y with the same base, which is log A. Okay, have you seen this before?
Yes, I think my teacher recently taught about the laws.
Okay, what does it mean by XY? So log A means log with a common base number, which is log 5. Log 5xy is basically separating these two terms here. Now, if it's multiplication, you can just add them up. Okay, if it's multiplication, so log A xy is log A x times y. So these two are together. Now, to separate them, you just put a addition operation. Okay, just put a plus sign there. It becomes an addition operation. So log x plus log y. When you solve it, you can solve it separately. Clear?
Yep.
Now, for the second law is when it comes down to division. If multiplication is addition, meaning you can convert a log term in the form of a multiplication expression like this, you can convert it into a term that is basically now adding each other up. For division, you can do the same, but it's the opposite way around. If it's x per y or x over y, it's log x minus log y. Okay, clear with this part? Can understand?
So it means that for law number one, it's usually plus, and for number two, it's always minus.
Division.
Uh,
Yeah. So when you have multiplication, you separate it to become plus.
okay.
Okay, one term plus the other. When it's division, you separate them to a subtraction or expression. So like this lah, log x minus log y. So one minus the other. That's all. Okay. So in a nutshell, you can separate any term that is given to you depending on the nature of that term. xy is a term. Okay, xy is a term. So x multiplied by y is the nature of that term. So when you put a log in front of xy, you can separate it into a operation that involves addition. Likewise for x over y. X over y separates itself to become log x minus log y. Clear?
Clear.
Okay. Now, the third rule of logarithm is when you have a power. Okay, now this is a very, very common question in your exam. Doesn't matter which board it is, but the question that comes out very often is when they give you a term that has got a power. Now, how do you rewrite the term? Now, remember this, for logarithm, there's a lot of proving questions. Okay, there are a lot of questions where you will need to prove something. Now, certain times they give you an expression that contains a term with a certain power. To rewrite the power, always remember when you're given something like this, say for example, log with a base 5, y power 5. So if I were to rewrite this, the power has to come in front of the whole expression. Is that clear? The power has to come in front of the whole expression. So
Yes.
log 5y becomes 5 log y. Okay, now I want to ask you a quick question. What happens if this is log 5, 5 to the power of 5? How do you write it?
5 log 5.
5 log 5, 5, right? Okay,
Yes.
now remember this. If your number base here or your log base here and your term here is the same, the whole value of log and that term becomes 1. So if it's log 5, 5, the whole value is 1. Okay, now this applies for all logarithm bases. If it's log 10, 10, okay, now I want you to just try a quick exercise. Take your calculator, press log 10. Your calculator log is with respect to base 10. So press log 10, 10. What do you get?
Okay. 10.
Log 10, 10.
Yeah.
Sorry, no, not log 10, 10. Just log 10. Just press log 10.
Oh, that's equivalent to 1.
Yeah. Okay. That is because, remember when we rewrite log in the form of indices?
Uh-huh.
Remember last week's lesson? How do
Yeah.
you rewrite log in the form of indices? So, log 10, 10 simply means 10 to the power of a number is equivalent to 10. You understand? So that number is 1.
I see.
Okay. Remember last week's lesson, right? Not
Yep.
last week, sorry. On Wednesday. Wednesday we did log.
Yes.
Okay. So later you'll look at some questions just as refresher. Okay. Now I want you to get this. I want you to register this and remember this. Okay. So when you do your exercises, you can remember, apply, and enforce it in your memory. Okay. So now you're introduced to it. Of course, you were introduced to this by your teacher in school. Now we are going through this again. After this, when you do your exercise, it will reinforce the concept in your memory. So keep practicing the work that we do. Understood?
Yep.
Okay. Now, I want you to look at these two warnings here. Okay, the two warnings that I've included here. Now, log x over y cannot be written like this. Yeah. Okay. Log x over y cannot be written like this. Okay. This term or this expression on the left is very different compared to the expression on the right. Now, to test this out, let's do a simple exercise. Okay, you have your calculator with you?
Yep.
Okay. Now, I want you to press log, open brackets, 5 over 4, close bracket. What do you get?
What is that? Repeat again. Log 5.
Log, open brackets, 5 over 4, close bracket. Okay. Log, open bracket, 5 over 4, close bracket. What do you get?
0.096.
Yeah, 0.096910013, right?
Yeah.
Okay. Now, I want you to now, okay, just write down the answer first, 0.0969. Just leave it at 0.0969. So you have your first answer. So write down the expression log brackets 5 over 4 equals to 0.09691. Okay, done?
Yep.
Okay, now I want you to repeat this, but this time we put log 5. Okay, log 5. Sorry, before we put log 5, open brackets, log 5, close bracket, divide, open bracket, log 4, close bracket. Done?
Oh, divide. Yeah. Okay.
Okay. What do you get?
1.16096.
1.16096. Do you see that the answers are different?
Oh yeah.
All right. So remember this, yeah. When you see a division term, do not separate the log. The log belongs to both of them, but when you convert the term, it has to be a term that subtracts another. So it is x minus y. It is not x divide y. Clear?
Clear.
Can understand?
Yeah.
Okay. The second one here, if you see the power outside a bracket like this, you cannot write it in this form. You understand? Because this power belongs to the value of log x, not x. Is that clear?
Oh.
Okay.
Yes.
Okay. So
Forgot.
to try that out, I want you to do a very simple exercise now. Okay. Press log 2 square. Log 2 square. What do you get?
0.602.
Okay. Now, write that down. Log 2 square is 0.602. Log 2 square. Okay, 0.602. Now, repeat the same thing. This time, open brackets, log 2, close bracket, square. Okay. Open bracket, log 2, close bracket, square. You get what?
0.0906.
Yes. Very different, right?
Yes, sir.
Correct. So now, clear with this?
Yep.
Okay. Now, I want you to remember them. Okay. Remember these three laws. Okay. Now, we'll look at an example. Let's try some questions. Okay. I want you to try. I want you to try question A, question C, question E, and question F. I repeat, question A, question C, question E, and question F.
Okay. All right. I am done.
Okay. What did you get? A?
Yeah, I got log A3 plus log AX.
Yes. Log A3 plus log AX. What about question C?
5 log AY.
5 log AY. Very good. Next. For E,
Log A x squared minus log A square root of y.
are you sure that's the final answer? Can
Minus.
we go further than that? Okay, come. Let's do it together. Okay, I'm gonna try and share my camera screen. Just have a look there. Wait. Okay. Are you able to see the camera screen?
Yes.
Okay. Now, what we have here is log a x square over 1, I mean square root y. Log a x square over square root y. So our first step is to separate them, correct? Log a x square minus log a square root y. This is 2 log ax, correct? Minus, this is log a y to the power of half, correct? Not?
Yep.
So this becomes 2 log ax minus half log ay. 2 and half, can I remove or not?
Yes.
How?
You cut out the 2 and the 2, you get 1, so you don't write down the 1. So it'll be log ax minus log ay.
So 2 divide half, what do I get?
1. Oh, 2.
Get 104, right?
No, I get 104, yeah.
Right? So in this case, if I were to take out 2, I'll have to put 104 here. So what I'm going to do is I'm just going to leave it like this. So my final answer would be 2 log a y minus half log a x. That's the answer. Sorry, this is x and this is y. Clear?
Clear.
Okay. Now for question F. For question F, what's your answer for question F?
Oh, I had to do F as well.
Can you try F?
Yeah, okay, yeah. I have a question.
Yep.
So, what do I do with the a squared?
What do you do with A? Okay, very good question. Okay, now, what do we do first? What do we do first?
We separate the thing. We separate the equation.
Okay. Wait, can you hear me?
Yes.
Okay. Now, for f, what do we do first? What's the
We
first step?
separate the y over a squared x cubed.
Okay. The first step, okay, if you look here, the biggest problem I'm having right now is the square root, right?
Yeah.
I need to remove this square root. So I'm going to put this whole thing to the power of half. Can I do that?
Okay.
Okay. You get what I'm trying to do? So
Yeah.
look at my camera screen. Log a square root y a square x cubed. Okay. Log a y a square x cubed. The first thing I'm going to do is I'm going to change this whole thing to log a y, sorry, y over a square x cubed power of. Can I do this?
Yeah.
Can. Okay. Now, this one here now becomes log a y power of half minus log a square x cubed power of half. Correct?
Yes.
Okay. Let me rewrite this in a proper page. Log y power of half minus log a square x cubed whole thing power of half. Can?
Okay.
Can I bring the half in front?
Uh, for y, yes.
For y, yes. For this one, cannot.
I don't think so because there's a bracket.
Okay. This whole thing, this whole thing is a single expression with this power, correct?
Yes.
Okay. What if I do this? Half log y minus half log a square x cubed. Because this a square needs the half, x cubed also needs the half. So I can bring the half in front. Clear?
Yeah.
Okay. So this becomes half log y minus log a square x cubed. Big bracket. Clear?
Yeah.
Next, what I'm going to do is I'm going to split this couple up. So half log y minus bracket 2 log a plus 3 log x. Okay, can you see that?
Okay, I see what you did. Okay.
All right.
Yeah, I see what you did.
Okay, now I'm going to expand the whole thing. So this becomes half log y minus 2 log a. My log base is what just now? A, right? Negative times positive becomes negative. Clear? Now, 2 log AA, this becomes 2. Half log Y, brackets, minus 2 minus 3 log AX. Multiply them in, this becomes half log AY minus 1 minus 3 over 2 log AX. Clear?
I kind of lost it the last part.
This part here.
Yeah.
Half times log AY becomes half log AY, right?
Yes.
Half times negative 2 becomes negative 1, right?
Yes, yes.
Half times negative 3 log AX is negative 3 over 2 log AX. That's all.
Okay.
Clear?
Clear.
Now you know how to do. Okay. So, step by step. Do one. Open up. Open up. Solve the middle one. And then times it back in. Okay. You can leave it like this. You can also do it like this. Doesn't matter. Clear?
Yep.
Okay, good.
Could you
If you
kindly
need, sorry,
could you kindly send me a picture of the working?
the working just now.
Yeah.
Okay, look at the main screen. It's there.
Okay.
Okay. You want to copy it down?
Yeah. Okay, I got it.
Okay.
Yep.
All right. Okay. I want you to try question A and question C. Question A and question C. I'll show you question A, then you try question C. Can?
Ken, I was about to ask you what do I do? Cause
Okay.
all the base numbers are 2 2 2 2. So what do I
Okay.
do with the?
So this is how you do it. See, because it's all the same bases, you can rewrite them. Remember your first rule, multiplication and division. So if it's multiplication, it's plus. So this one, if you write them backwards, it becomes log 2 7 times 12, correct or not?
Yeah.
Okay. And because you have the same base for the third expression, that means they're all part of the same term. So this is log 7 times 12 divide 21. You're going to get log 24. Log 24 can be written as log 2 square, correct or not?
Oh yes, yes, yes.
Okay. So you can basically write it like this lah. Log 24 equals to log 2 square, which becomes 2 log 2. This is equivalent to 1. So your final answer is 2 1. 2 1. So, yeah. Okay. So, can you try question C?
Ken.
Can?
Wait, I just a bit more. So I have a question.
Yep.
So if you were to write it down, right,
Okay.
would it be like log 10, then we do 2 open bracket 3 close bracket 3 over 3 plus 3 1 over 3. Is
3
that how
plus
you write it down?
3 1 over 3.
Because it's like
Okay. How I would do it is I would write log 10 3 square times brackets 3 sorry, not times 3 divide 3 times square root cube root 3. Okay, let me just show you how it's done. C, right? Okay, it's like this. Okay.
oh, okay.
Okay, so basically what's happening here is you've got 3 square, that's 9, minus is divide 3, plus is multiplied by log 3 1 over 3 is, wait, log 10 log 10 1 over 3, wait, 3. Oh, 3 1 over 3. Okay, okay, okay. So it's 3 1 over 3, then it's quite easy to solve lah. Okay. Look at my camera for a while. This is how you do it. So you see here, what I'm gonna do is I'm gonna write log 10, big brackets, 3 square, correct?
Yes.
3 times. Okay. 3 square. Oh, no, no, no. Sorry, 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 sorry. This is 3 times 10 over 3. So 3 times 10 over 3, 3 square Okay, so here I'm not sure why they put. Oh, okay, okay. It's a continuous. Okay, sorry, I got it wrong. Supposed to be this. Two, 1 plus. Wait, 1 plus. This is 4/3. 3 to the power 4/3. No, can't be that. 9 times 10/3. You get 30. 30/3 is log 10. So 9 divided by 3. Ayah. I keep writing it as 3 to the power 1/3. I forgot it's 3 1/3. So it's 3 times 10/3. 3 square. So 3 times 10/3. So, no, sorry, this is deep. Sorry, let me just write it back. 3 square minus, so divide 3 times 3 1/3. This is proper. Okay, so this is 9 divided by 3 times 10/3. Okay, 3 times 10/3 is 3 times 10/3. This becomes 30/3. 9 times 30/3. Wait, 3 square divide 3. 3 square divide 3 times 3 1/3. Okay, correct. So 9 divide 3 is 3 times 10/3. So you get log 10, 10, which is 1. Can understand?
Oh,
Okay.
so what happened to the 9?
So log, okay, this is actually what happened, the whole picture, yeah. 3 square times,
Divide.
divide 3 times 3 1/3. Now what I'm going to do is, I'm going to solve it like a normal expression. So this becomes 9 divided by 3 times 3 1/3. So here 9 divide 3, I'm going to change this to improper fractions. Okay, so here 9 divide 3 is 3. So 3 times 10/3. I'm left with 10. Log 10. Log 10, 10 is 1.
What?
Clear?
Oh, yeah. Yeah, yeah.
Okay.
Yep.
Can, yeah?
Should it be a problem?
Okay. You want to try D? Oh no, we've come to the end of class. Okay. What you can do is take down D as a question. Try D as
Okay.
your homework. Okay.
Can I copy down the way to do it for C as well?
Can. Can
Okay.
can I scroll up?
Yes. This way.
Okay, you can copy down. In the next class, I'll explain to you how to do if it's a different log base. So now you're doing with all similar log bases, right?
Yep.
Okay. So the next class we'll look at how to do when it's a different log base that we are operating with. Okay.
Okay.
Let me know once you have copied D. Yeah.
Yep. Done.
Done. Yeah. Okay. All right then. So I'll see you on Monday.
Okay.
Monday we'll continue with the part that I told you earlier, the one that has got different log bases. And the thing with logarithms is, after I'm done with this, I will give you a worksheet to try. There's answers also in the worksheet. I want you to try them. It's just simple exercises, but it will go a long way if you can do them all. Lah. Okay.
Okay.
All right. So,
What
yeah.
time is our class on Monday?
Monday, you're back to school on Monday, right?
Yes.
Yeah. So class will be the same time, lah, around 6:30.
Okay.
Okay. All right then. So I'll see you on Monday, yeah, Faiz.
Thank you, sir. Bye bye.
All
Have a
right.
great weekend.
You too.